Lesson 7, Adding and Subtracting Radical Expressions. So let's take a look at what like radicals are. Like radicals work very similarly to like terms. For example, 3x and 2x are like terms, which means that we can just add the coefficients together. So we get 5x. And we can do this because they're like terms. Same idea for like radicals. We have the radical portion here. I know that this radical portion are the same. So these two terms are like radicals, which means I can just add or subtract the coefficient of those radicals. 3 plus 2 is 5. And then we have square root of 2. Like radicals have the same index and same radicand. Step 4, adding and subtracting like radicals. First, check if radicals are like. If not, do any simplifying. Step 2, add or subtract coefficients, leave radicals the same. Simplify. We have these two terms, and I know these are like radicals, so I can just subtract the coefficients. The answer is 5 root 3. Same idea for the next one. We have the radical portion, cube root of 10 in each term. So I can just add or subtract the coefficients. So negative 5 minus 6 is negative 11 cube root of 10. Moving on to part C. This time we do have radicals in both terms, but the first term has a square root and the second term has cube root. So we cannot further simplify. Let's take a look at part D. We can confirm that there's square root in both terms, but the radicands don't match. Let's rewrite 2 times square root of 75 so we can perhaps make them into like radicals. First, we write the 2, the coefficient alone, and we're going to look for perfect square factor of 75. It's 25 times 3 equals 75 plus 3 times square root of 3. I can rewrite square root of 25 times square root of 3 and keep the rest together. I know square root of 25 is just 5. And lastly, we can do 2 times 5, which is 10, root 3 plus 3 root 3. Now we have like radicals. So we can add the coefficients. So 13 root 3. This will be the final answer. Part E. Same idea with part D. We do need to check if we can rewrite these as like radicals. I know 27 is 9 times 3, where 9 is a perfect square, plus 3 root 5, and I can't simplify any further, minus 16 times 5 would equal to 80, 2 times square root of 4 times 3. I know these are perfect squares, so I can take those out. I have negative 3 root 3 plus 3 root 5 minus 4 root 5 minus 4 root 3. Now let's take a look. So there's root 3 and root 3 here. So I can combine those together and we have root 5, and root 5 together. So we have two sets of like radicals. So let's combine those yellow ones together. So negative 7 root 3, and then blue ones together, negative root 5. This is the simplified form. Part F. First, I would like to simplify this part because that is a perfect square. So we have 3 root b, and I know this part 16 is perfect squared. We have 3 times 4 root b. This becomes 3 root b minus 12 root b. And now we have like radicals, so we can just subtract the coefficients. So we have negative 9 root b. We can't stop right here because we do have a variable under a radical sign. This means we need to make sure that b is greater or equal to 0. So we do need to restrict the variable b so that square root of b is defined. In example F, why does b have to be greater than or equal to 0? If it was negative, the radicands would become negative and square root of b becomes undefined. Moving on to example 2. Simplify. Part A. First, we need to state the perfect square factor to simplify each radical. So I know 27 is 3 times 9, and x and y cannot be further reduced. And we have 8, which is 4 times 2, and there's x and y. So highlight the perfect squares and rewrite 3 times square root of 3xy plus 2 times square root of 2xy. We cannot further simplify because these are the furthest we can go to make it look like a like radical, but unfortunately we have 3 here and 2 here inside the radical. This means these two terms are not like radicals. This is most simplified form. Now let's take a look at part B. We have cube root of 16 and cube root of 54. We could perhaps simplify a little further. So this time we're looking for perfect cube to take out. So we leave the coefficient in the front and find the perfect cube factor. I know 8 times 2 is 16. And I also know that 27 times 2 is 54. So I can take these out. We get 4 times 2 times cube root of 2 plus 3 times 3 and cube root of 2. Multiply 4 and 2. 8 times cube root of 2 plus 9 cube root of 2. And this time we do have two like radicals, so we can just add the coefficients together. 17 cube root of 2. Now let's take a look at part C. We have radical portion here, and let's try simplifying further. We write the first coefficient first, and then find the perfect square factor of 63. We know 9 times 7 is 63, and 9 is a perfect square. The second term would be this way, and perfect squared factor of 28 is 4. 4 times 7 is 28. Alright, so let's take out, or let's highlight the perfect squares. This one, and this one, and this one. We have 3 times 3x, and the radical 7y. We have 5 times 2 times x, and then inside the radical we have 7y left over. We can simplify by multiplying the coefficients together, keep the radical portion, and then we can confirm that we have the like radicals. Simply, we just do 9x minus 10x. We have negative x times square root of 7y. This is our simplified form. And also, because we have the variable inside the radical, we do need to state the restriction that y must be greater or equal to 0, just like the question stated. Let's look at the last example. We have coefficient 5 over 2, and this time we have cube root in each term. Let's simplify this further. We keep 5 over 2, and then this time we're looking for perfect cube factor. We have 8 times 2, which is equal to 16, x cubed times x equals x to the power 4, and then we have y cubed times y squared, which also equals to y to the power of 5. We'll do the same thing for the next one. We keep the coefficient, x and y, and then open the cube root and find the perfect cube factor. So 27 times 2 is 54. We have x and y squared left over. Let's highlight the perfect cubes. We have 8, x cubed, y cubed, 27. That's it. So let's take them out. 5 over 2 times 2 times x times y, and open the cube root, we're left with 2xy squared minus x times y times 3, open the cube root, 2xy squared left. So we have the radical portion here, and then it looks like these two terms are like radicals. So I can just add the coefficients together. But first, let's simplify. So 5xy cube root of 2xy squared minus 3xy times cube root of 2xy squared. And then 5xy minus 3xy is 2xy, and the radical portion follows. This is the simplified form of the original expression. So this is it for lesson 7. I'll see you guys in the next video.